Okay guys, so the second video we're going to be looking at for our class is about the design process. There are a lot of design processes that engineers use in the world when they do designing. However, for Project Lead the Way, and again, Project Lead the Way carries through high school, we're going to be all looking at the same process. So first of all, we're going to cover our essential questions. Again, these are the things that you should be learning as you watch the videos, and by the end you should be able to answer these questions. Okay, so first of all, why do we need a design process for this class? Second of all, what is the difference between criteria and constraints? That's an important one. And also, in the design process, what is the purpose of the arrows that you're going to see on the diagram? So again, as we go through this lesson, these questions should be answered. These are things you should be thinking about. So first of all, we're going to talk about, and again, you can see on your notes where you're going to fill these things in. What is design? Remember, I want you to put this in your own words. It's going to be kind of wordy, but you can definitely put in your own words. And a good way to do it is to put examples if it helps you. So first of all, the word design, as used in our class, is defined as anything that was made by human effort, basically. So basically anything that is created and made by humans. We use design to systematically solve problems. What that means is we design things to solve problems. The heart of design is to solve a problem. It doesn't mean, your sink is clogged. It means that there is a need for something in the world, whether it be a new product, or it could just be a system that will make things easier, or it could just be a situation in life that isn't as good as it could be. We use design to solve these sort of problems. Again, remember that you can pause the video when you need to write things down, and you should. The second part is, what is the design process? So first we talk about design. What's the design process? Well, again, this is very wordy and very official definition, but it's a systematic problem-solving strategy. Okay, the word that I'm emphasizing here is systematic, meaning there is a system, there is a way of doing it. It's not just random, it's not just chance. You're going to follow a system. Notice there's those words, criteria and constraints, we're going to talk about. And the idea is not just to develop one idea, but to develop many ideas and then just select one final idea. And this is a big emphasis of what we're doing here. When you guys work in groups with teammates, you're going to have many ideas. And you're going to have to figure out, how are we going to decide which idea to go with? Sometimes what happens in groups is you just sit there and argue and the wheels spin, but nothing happens. We have a very strict process that we're going to follow that will help decide this. And this is a type of process that you might find engineers use. First thing we're going to do is we're going to differentiate between criteria and constraints. Criteria basically, and again, this is wordy as I said, they're basically the requirements that have to occur for the project to be successful. So these are the things that have to happen. That's what the criteria are. An example that I came up with was, you could be making a chamber that must have a surface area of 10 square feet and a volume of 3 cubic feet or less. So there are some criteria that will make this product work. Constraints are sort of the other end. Constraints are limitations. So criteria are things that have to happen. Okay, constraints are things that are basically making it difficult for the project to happen. So they could be things like you only have a certain amount of time, the cost could be limited, or going back to our chamber example, it could be that you have to be able to access it from inside of a spacecraft or from inside of a building. Now you can no longer go outside of the spacecraft, go outside of the building when you're designing. So it's basically restricting your design versus the criteria, which are things you have to make sure are included in your design. Okay, we're going to briefly look at a couple of things. One is the design brief. Okay, a design brief is basically what the engineers are going to use when they create solutions. But it's kind of sort of the be-all, end-all. It includes everything that we're going to do, documented in our notebooks. So first of all, it's a written plan. Okay, it's not a random plan where you kind of just have to write whatever and make stuff up. It follows the process, the design process that we're going to learn about today. But the key is it's a written plan. It's not in our heads. It has to be written down. Okay, it identifies a problem to be solved. It's criteria and it's constraints. So it's sort of like saying, okay, here's a problem that we need to solve. Sometimes that problem's given to you. Okay, or it could be something you're identifying yourself. So here's a problem. Okay, what are the things that have to happen for that problem to be solved? And then what are some things that are going to make it difficult for us to solve that problem, or things that are limitations on what we can do. The second part, its purpose is to encourage thinking, it's the big part here, about all parts of a problem before you try to come up with a solution. So the whole idea behind a design brief, and this is important, the whole idea behind that is that we want you to think before you start going into a solution. When you start to make your solutions, you've already put a lot of thought into it, you've already had opportunities to change your mind and revise, and you've already looked at what other people have done. Okay, and the last thing on here is, what is a decision matrix? It's kind of a weird thing. I have a picture of one here for you. And this is generic because you can see it just as idea 1, 2, 3, 4, 5, 6. When you're in a group and you come up with many ideas, the idea here that we're trying to wrap our heads around is, how do we decide of those 6 ideas what's going to be the best for us to go with? Okay, like how do we have a best idea? So this is not necessarily always what's going to happen, but the ones that they looked at on this decision matrix were the cost, the complexity, the development time. Okay, and those were the 3 things that they focused on. What they did is they said, okay, well, low cost is going to be a 4, high cost is going to be a 1. And so a couple of the ideas had very high cost, a couple of the ideas had very low cost. And they kind of wrote that in there based on that. It's just a 4-point scale. The least expensive, the most cost effective are a 4. The next is a 3. Complexity, how difficult is it? Okay, a 4 doesn't mean it's very difficult. 4 means it's very simple. And so when you're deciding ideas, you have to kind of have that sometimes. Okay, development time is, how long is it going to take to build it? You know, you can make a project that has super high cost, is very complex, and takes forever to build, but people aren't necessarily going to want to pay you to do that. So when you talk about what we're doing in our class, we have to be realistic. If something's going to take us a ton of time and we don't have that time, then that's going to be a low-rated item. One of the keys here is, even if it's your idea, you have to look at it without bias. You have to say, well, you know what, it is a cool idea, but it really is going to take too long, or it really is going to be too complicated. And sometimes you take a step back and you don't go with that idea this time. There's always other opportunities to come back and revise. And maybe what I like about this is you share each other's ideas and you sometimes take pieces from each idea. But as you can see here, what ended up happening was it wasn't the most cost-effective one, idea number 6, but it was simple, and development time wasn't going to take very long. So because of that, that one ended up with a score of 11. They added the scores left to right, and based on that, they would now go with idea number 6. Now you might say, okay, well now it's down to idea 3 and idea 6. You're not stuck using the decision matrix, but it's helping you decide. Clearly, idea 2 and idea 1 are not as good ideas. That doesn't mean they're not very creative. It just means that due to the complexity and the time it would take and the cost, it's not something that you're going to go with. And again, like I said before, this is a tool. It's something that we're going to use to compare ideas and figure out which one's going to be the best. So you have an opportunity to write a little bit on your notes just to the right of the decision matrix that I gave you on the paper. So now what we're going to do is we're going to jump right into the back of your notes page, so you can flip it over to the back. As you can see, there's a lot to fill out. What we're going to focus on here is we're going to go through all the steps of the decision-making process, the design process. We're going to start off with step number 1, which is defining the problem. Okay, and as we go through this, we'll talk about what each step means. So what does define the problem mean? Okay, and you're not always going to have to recite all these things, but I want you to clearly understand what each step means. So off to the side of it, we're going to start filling these things out. First off, defining the problem means identifying the project problem. So given the project, what's the problem that's going on? Okay, and it's not as simple. They could be asking you to build something, but you have to kind of think, what's the reason why they're asking me to build this? What is the problem that's occurring that needs to be solved? Who says it's a problem? Is it just you that thinks it's a problem? Is it the company that thinks it's a problem? You need to make sure it's a valid problem. Is this problem even worth solving? And that's a weird question, right? Every problem you're given in school, you're told you have to solve it. In this, it's like saying, okay, is this problem even worth solving? Now we have to look at our criteria and our constraints. Okay, what are the things that have to happen, and what are the things that are going to make it difficult to happen? And at the very end, you're going to create a design brief, okay? Remember, that's the part that is a written plan for your entire design. This is part of define the problem. It's part of the first step to create a design brief. Now, before you move on, you're going to ask yourself a question. You're going to say, is the problem valid? Okay, if the problem is valid, then you continue to move down to the next step 2. If the problem's not valid, if going through these steps it just doesn't seem like it's going to work, then that's why the arrows go off to the right and back up. You go back to the first step and you start again, define a new problem and go from there. This whole entire process with all the arrows you're seeing is meant that you can always go back to an earlier step. In fact, you can always go back to any earlier step that you'd like. The second piece is that we're going to generate concepts. What that means is we're going to research and brainstorm solutions. This is not one person, this is everyone in the group does this. Then we're going to consider additional goals. Is there anything that we could add on that this thing could do? Any other problems that could be solved that we haven't thought of yet that besides the main problem? We're going to select an approach, okay? Meaning we're going to go ahead and pick one that's best, and the way we do that is decision matrix. So that's what we just learned a second ago. So after you do that, and after you generate your concepts, you're going to, again, ask yourself a question. Does the technology even exist to solve our problem? Let's suppose you say, well, the best solution here is to get into a time machine, go back in time, and fix it yourself. The technology doesn't exist for that. We can't go forward with plans that require things that have not been, invented yet. So what that means is you're going to need to have scientific research first. So what it's suggesting is we need to do some scientific research to get ourselves to the point where we can actually use these plans. And then what you have to do is you have to either go back to generating more concepts, maybe going to the next thing on the decision matrix, or go all the way back to the beginning, define the problem again, and start over. If, however, the technology does exist, this is something that's doable, now we're going to develop a solution. Okay, we're going to create a detailed solution. Okay, what that means is we've come up with some ideas, now we're going to develop one. We're going to justify the solution path. You can't just have a solution, you have to justify why it's going to solve the problem you're looking for. You have to do technical drawings. This is a big piece of engineers, and that includes the materials you're going to use, the size of the thing, and the shape. And these are some things that we're going to learn in this class, how to draw the correct sizing so people know the sizes, and how to figure out shapes that are best used. Okay, again, we're going to ask ourselves a question. Is this solution valid? Does it solve the problem? If the answer is yes, we continue to move down the list. But if the answer is no, we go either back to generating concepts again, where we come up with our possible solutions, or all the way back to defining the original problem if needed. Okay, step 4 is constructing and testing a prototype. So now that you've come up with a solution, you don't just jump into the factory and make 10,000 of them. You go ahead and you create a prototype. Prototype is basically just a test example. Okay, so to do that, we're going to have to construct a testable prototype. That's the whole point. It has to be something that can be tested. The computer programs are interesting because sometimes you can test things on these computer programs. But for you just to draw something on a piece of paper is not a testable prototype. You have to actually create something and test it out in the real world. Okay, so we're going to plan what to test. Okay, so what are we testing on it? Are we testing how strong it is? Are we testing, the wind that goes against it? What exactly are we testing? And we do that before we test the prototype. Okay, then we test and collect and analyze data. And that's a lot of things all at once right there. Basically, if you go through the process, first we build it, then we think about what are we testing, then we test those things, and then we analyze that data. Okay, so it's not enough just to test it, you have to analyze what does it mean, and then you create a report. Okay, again, we're simulating the way an employer would want to, get this report from their engineer that was working on their task. Okay, so was the prototype valid? You have to ask yourself that question. Did the prototype hold up the way we thought it would? If not, as you can see, you go back. You got to go back and generate new concepts or any other step in the process. So you have to go back and do it again. You could recreate a new prototype, but if your prototype is accurate to your plan, your solution, that means that your solution was a little bit flawed. You might want to go back up to the generating concept step. That's why the arrows go all the way back up there. Or even possibly redefining the problem. Maybe the prototype isn't solving the problem. Everything worked good, but the prototype doesn't solve the problem you want. You may have to go back up and redefine it. Step 5 is evaluating your solution. Now that you have a solution, was it as effective as you wanted it to be? Did it solve the problem? Recommend some improvements. Okay, this is not the end of the road. This can be the first step, and innovations can occur after that. But recommend improvements to it now that you've seen things. Revise and redesign if you can. Okay, so if you need to revise things, you can do that. And then finally, project recommendations. So now you're at basically the evaluation of your solution. You're going to make your project recommendations to your team and to your employer. Before we move on, we're going to do one last step, which is to
Does it solve the problem? So if the answer is no, you're going to have to go back and either generate new concepts or redefine the problem. If you went through the process, everything was viable, everything was right, and when you created a solution that didn't actually solve the problem, then probably you defined the problem incorrectly. So you either defined the problem incorrectly to begin with, or the concepts you came for weren't really solutions. So that's why you go back to either one of those steps. But if everything's good, the problem is now solved, you present it. And that's a big piece of it. You don't just live in a world where you don't have to share what you've created with the person that's employing you. So now you would present your solution, which includes a complete project portfolio. This may sound like something you do for school, but engineers have to have that too. Document everything. That's a big piece of it. So everything is written down. Every mistake you make is crossed out. You don't erase. Okay, that's a very important piece. So you document everything, and the formal presentation to the customer, or in our case, a lot of times the teacher. So you would do a formal presentation. Okay, and it's a lot of work and something you've created, so it's a good and fun thing to do. And that's basically the end of the design process. As you can see, we have one less bubble left there, and that also takes you back to the very first step. And what that is it's saying, okay, now you created a solution. Well, what if your product is innovated? So meaning, what if the solution you came up with is innovated, or what if the product that you were evaluating was innovated? And that's when product innovation just goes back through the entire steps again. A lot of people might think it might jump to just one of the steps along the way. But when a product is innovated, it's innovated for a reason. And often that reason is there's a new problem that comes up. You created something and all of a sudden something else doesn't work. So now there's a new problem, generate new concepts. And what you create at the end of the day is an innovation on the solution that was created by the other person. So hopefully this gives you a clearer picture of the design process. You are not going to be responsible to know every little piece of the process of define the problem, all the 5 things there. What I do want you to understand that you start with the definition, then you create ideas, then you really take one and run with that one idea and create a strong idea. Then you make a prototype of it. You test out the prototype and you present your solution. So that's kind of the process that we go through. So now below you'll see the conclusion questions I need you to complete. Make sure you do those 3 questions before you leave today.